Today we will discuss how to multiply two matrices. Suppose we want to multiply two matrices A and B. So if you want to multiply two matrices A and B, what should be the conditions on A and B? Let us discuss that first. The order of A, if it is m by n, then the order of B must be of order. The order of B must be of the form n by p. That is, the number of columns of A must be equal to the number of rows of B. This is the preliminary condition. And when you multiply A and B, you will get another product matrix C. And remember always, if you get what will be the shape of C? The form of C? C will be of the form. You are multiplying two matrices. One is m by n, other one is n by p. The order of the resultant product matrix will be of the form m by p. You leave out this n, you leave out this n. The order will be m by p. Now let us take an example. Let us take A is equal to, let our matrix A be 1, 2, 3, 2, 3, 4. Let us take like this, 1, 2, 3, 2, 3, 4. So what is the order of this matrix? This is 2 by 3. It has 2 rows and 3 columns. And let us take another matrix B. If you want to multiply A and B, then the order of A, the number of columns of A must be equal to the number of rows of B. So here the columns of A is 3. So always remember the number of rows of B also should be equal to 3. The rows should be equal to 3. So let us take it as 5, 0, 1 minus 1, and let us say take another one, 2, 4. So we can see here this is having number of columns is 3. So this is having number of rows is 3. Columns can be anything. So here we are seeing that the number of columns we have taken 2. Okay. But because number of columns of A is 3, here the number of rows of B is also 3. So we can multiply A and B. And now we can say that when you multiply these two matrices A, B, okay, what will be the resultant matrix C? The order will be, you leave out the middle 3, 3. The order will be, this is M, that is P. So order will be 2 by 2, M by P. So let us multiply. See the procedure of multiplication, how we multiply. So you're multiplying. How we multiply? We multiply first row of A with first column of B. We multiply first row of A with first column of B to get the first element of the product. So we multiply first row, first column. So 1 into, this is 5. Okay. 1 into 5, 5. 2 into 1, 2 plus 2. 3 into 2 plus 6. We multiplied. Next, to get the first element of the product matrix, we have to multiply first row of A with first column of B. And you can see here, as because 1, 2, 3, there are 3 elements, because it is having 3 columns. It is having 3 columns and it is having 3 rows. So I can have 1 to 1 correspondence. 1 into 5, 2 into 1, 3 into 2. That was the reason why we wanted the number of columns of A to be equal to number of rows of B. Because here we are having 3 elements, here also we are having 3 elements. Here 3 elements are there in the row, here 3 elements are there in the column. Because here the number of columns is same as the number of rows here. So we get the first element of the product matrix. Now to get the second element of the product matrix, because it will be a 2 by 2 matrix. That means it will have 2 rows and 2 columns. 2 rows and 2 columns. Now the second element of the product will be, to get the second element here, we have to multiply first row, second column. 1 into 0 are 0. 2 into minus 1 minus 2. 3 into 4, 12. Now we get the second element of the product matrix. Now to get the first element of the second row, what we have to do? Second row, first column. What we have done till now? First row, first column, we get the first element. First row, second column, we get the second element. To get this, we have to multiply second row, first column. 2 5s are 10. 3 into 1s are plus 3. Plus 4 into 2s are 8. We get this element. the first element of the second row. To get the first element of the second row, we have to multiply second row first column, second row of A, first column of B. Now to get the last element, that is the second element of the second row of the product matrix, I have to multiply second row into second column. 2 zeros are 0, 3 into minus 1, minus 3, 4 fours are 16. So that's what we get. 7, 6, 13, 12 minus 2, 10, 21, 13. So we get, this is our resultant product matrix, which is of order 2 by